No volcano in human history has ever been this terrifying. On January the 15th of last year, the Kingdom of Tonga experienced one of the most dramatic and catastrophic volcanic eruptions ever recorded. The Hunga Tonga-Hunga Ha'apai volcano erupted at such a force that water vapor was launched into space for the first time by an earthly volcano. Surprisingly, a volcano that is buried hundreds of meters under the ocean triggered it. Both the general public and volcanologists were surprised by the incident. The eruption in Tonga was so powerful that the atmosphere rang like a bell. Pressure waves sped throughout the globe in response to the massive volcanic explosion. Was this a brand new eruption kind that we had never seen before? Was it a warning that these underwater beasts are waking up? Let's find out. One of the 20 comparable volcanoes that make up the Tongan portion of the Pacific Ring of Fire is the Hunga Tonga-Hunga Ha'apai volcano. It is a relatively unknown seamount. A few of the surface volcanoes along this ring are Mount St. Helens in the US, Mount Fuji in Japan, and Gunung Merapi in Indonesia, all of which are well known. But little is known about the several undersea volcanoes that surround it. Numerous islands all around the world, including Hawaii, Indonesia, and Iceland, were created by submerged volcanoes. The term submarine volcano refers to a volcano that is situated beneath the ocean's surface. Submarine volcanoes act very differently from terrestrial volcanoes because they erupt into the water rather than the air. For instance, explosive eruptions from undersea volcanoes are rare. They experience extremely high pressure due to the sheer weight of the water above them, which typically causes passive lava flows to form along the seafloor. Most subsurface eruptions don't cause any surface turbulence. Magma supply and tectonic activity are the two key variables that cause undersea volcanoes to finally produce islands. You must first gather a quantity of magma. The Earth's mantle must typically be melted for the majority of oceanic island volcanoes or submarine volcanoes to form. Most active lava flows on the seafloor are the source of volcanic islands. Over millions of years, these passive flows solidify into rock and increase the undersea mountain's height. Some volcanoes eventually rise above the ocean's surface when the lower pressure permits violent eruptions. The South Pacific island nation of Tonga contains one of the planet's most recently produced volcanic islands. There are 170 volcanic islands in the Tonga archipelago. The new landmass was created in March 2009 when an explosive eruption covered the uninhabited island of Hunga Ha'apai, which was 63 kilometers, 39 miles distant, with black volcanic ash. The explosion blasted steam, volcanic gases, and volcanic ash around 800 meters or 2,625 feet into the sky. Days later, rock and debris from the original eruption merged with a second, smaller eruption from a vent between Hunga Ha'apai and the new landmass to fill the area between the two. A single landmass that was roughly double the size of Hunga Ha'apai's original size was the end consequence. The young island maintained its elevation above the sea since the 2009 eruption, and it expanded significantly since a series of eruptions in late 2014 and early 2015 increased its landmass. Scientists have estimated that the eruption of the Hunga Tonga-Hunga Ha'apai volcano, which took place on January the 15th, 2022, and was felt all over the world, probably involved 5 blasts based on eyewitness accounts, data from tide gauges, satellites, evidence of broken windows, and other sources. The final one released energy roughly equal to 15 megatons of TNT. That puts the volcanic event on par with the most potent nuclear weapon ever exploded by the US, the Castle Bravo bomb launched in the Bikini Atoll in 1954. it is roughly 1,000 times more powerful than the bomb that was dropped on Hiroshima in 1945. The research team, which is comprised of researchers from US and New Zealand institutions, added that the volcanic event, which took place 65 kilometers or 40 miles from the country's main island, involved both eruptions that sent massive volcanic plumes into the stratosphere and steam explosions that produced sonic booms, and were the primary cause of the associated tsunami. As the pulse passed through Europe, North America, India, and many other locations around the world, it caused minute changes in atmospheric pressure. As observers submitted their barometer findings to social media, viewers were able to track the pulse's development online in real time. In around 35 hours, the wave traveled the entire globe and back. A particularly striking example of the phenomena of the global propagation of atmospheric waves, which has been observed after other significant explosive events, include nuclear tests, was the growth of the wavefront on the Tonga eruption. Although at a frequency that is too low to be audible, this eruption was so strong that it made the atmosphere ring like a bell, although that wasn't the first of its kind. The massive eruption of Mount Krakatoa in Indonesia in 1883 caused the first pressure wave of this kind to draw scientific notice. At locations all over the world, barometer observations revealed the Krakatoa wave pulse. Obviously, communication was slower back then, but after a few hours, scientists merged the different isolated observations and were able to plot the propagation of the pressure front in the hours and days following the eruption on a map of the entire world. The wavefront was seen moving away from Krakatoa and making at least 3 full orbits of the Earth. Very low frequency sound waves are what are visible following Krakatoa, or the most recent eruption in Tonga. Localized pressure variations exert a force on nearby air, which then accelerates and experiences an expansion or compression along with corresponding pressure variations. These forces air further along the wave's course. In our everyday encounters with higher frequency sound waves, we anticipate sound to move in straight lines, for example from the exploding rocket of a firework right to the ear of a spectator on the ground. However, these global pressure pulses have the odd property of only spreading horizontally, bending as a result of following the curvature of the Earth. Based on a variety of data sources and computer simulations of the event, researchers claim that Tofua Island's western coast may have been subjected to waves as high as 45 meters. They claim that this conclusion is supported by vegetation scars seen at the same altitude and recorded by satellite and drone data. People as far away as Fiji, which is around 500 miles away, reported feeling the earth and buildings shake for hours as a result of the eruption. The Hunga Tonga-Hunga Ha'apai volcanic event is believed to have killed 6 people, including 2 people in Peru and 4 people in Tonga, who drowned as a result of the unusually high waves brought on by the volcanic activity. According to the researchers, it would have been predicted that the strong waves in some areas of Tonga would have led to a higher death toll, but this was not the case. According to a recent study, the Tonga volcano eruption produced the highest ever plume, with an ash cloud that rose 57 kilometers, that's 35 miles. The Pacific seafloor has also suffered significant changes as a result of the eruption, according to data from the Tonga Eruption Seabed Mapping Project, TESMAP, and it no longer looks as it did before. After the explosion, the volcano released a total of 9.5 cubic meters, that's 2.3 cubic miles of material. This would be sufficient to build 4,000 enormous pyramids like those in Egypt. The TESMAP study claims that the eruption was so strong that it produced pyroclastic currents, which are fast-moving masses made of gas, lava, and ash, and whose debris may be discovered up to 50 miles or 80 kilometers away from the explosion's location. The material the currents were carrying had a temperature of 1,830 degrees Fahrenheit, that's 1,000 degrees Celsius, and it was moving at a speed of 435 miles per hour, that's 700 kilometers per hour, which is almost twice as fast as a Formula One racing vehicle. Surprisingly, the Tonga volcano's sidewalls were unaffected by the pyroclastic currents, which nevertheless caused the Pacific bottom to tremble and generated tsunami waves. However, during their investigation, scientists from Auckland's NIWA National Institute of Water and Atmospheric Research discovered that the volcano crater's depth had now expanded by 700 meters. The TESMAP experiment also shows that despite the havoc caused by the currents, there are still locations right beneath the volcano where life is thriving. It's like a desert 70 kilometers away from the volcano, but strangely, there is life just below its rim in locations that have managed to dodge these density currents. The authorities can precisely identify the danger zones surrounding the Tonga volcanic region using the survey's data. With this knowledge, we would also be able to determine which places are suitable for human activity in the future and which disaster management techniques might be used to lessen the effects of any potential future disasters. The strong eruption, which was visible from space and was picked up by a variety of sensors all around the world, reportedly boosted the amount of water in the stratosphere by 10%. The ozone layer, which shields the globe from damaging UV radiation, is found in the stratosphere, the second lowest layer of the Earth's atmosphere. Now that the Hunga Tonga volcano's water emissions have significantly cooled in the stratosphere in southern mid-latitudes, that ozone may be in danger. Ozone deterioration is accelerated by stratospheric temperatures that are cooler. This is due to the fact that scientists see the creation of polar stratospheric clouds, thin, ghostly clouds drifting up to 9 to 15 miles or 15 to 25 kilometers above Earth, more frequently when the stratosphere is cooler and there is a lot of water present at those altitudes. When these clouds form in the winter, when the stratosphere is at its coldest, chlorine-based ozone-depleting compounds, which were outlawed in 1989 but are still present in the air above Earth, can deplete ozone in the atmosphere. However, scientists are not alarmed by this brief expansion of the ozone hole's extent. The World Meteorological Organization (WMO) has recently reported that Earth's protective ozone layer is recovering from the ozone depletion brought on by chemicals containing chlorine and bromine that have been used as refrigerants and aerosol sprays since the 1950s. In the 1970s, scientists first realized the ozone layer was thinning and that there was a huge hole above Antarctica. They immediately identified the cause. The ozone layer was becoming less effective, allowing more harmful UV light to reach the Earth's surface. Studies suggest that between 1982 and 2010, the incidence of melanoma, a kind of skin cancer linked to damage from UV light, increased by 60% in Australia, the region most affected by the ozone layer deterioration. According to a recently published study, the ozone layer should primarily recover globally during the next 2 decades. The Antarctic ozone hole won't close completely for a while, but experts believe it will be gone by the middle of the 2060s. However, a year and a few months later, we are all aware of the disastrous effects of submarine volcanic eruptions. Volcanoes are highly interesting to observe because of the numerous dangers they pose, including sudden explosions, landslides, and long-term climatic disturbances. A stark reminder of the dangers of residing on or close to one of the numerous volcanoes, active or supposedly dormant, across the world are the ruins of Pompeii, Italy. More recently, in 1980, Mount St. Helens in Washington state erupted, ripping more than 1,300 feet off the mountain's summit and resulting in an estimated $1.1 billion in economic losses due to deaths injuries, bridge destruction, and lost crops, among other things. The Tongan eruption is a wake-up call to watch every volcano. Even inactive or dormant volcanoes can turn out to be dangerous. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.